All right, two big facts. Let's go back to Unit 4. Angle 1 is called the what type of angle in that triangle? Exterior. Yeah, we learned something about an exterior angle and how to find it in Unit 4. Angle 1, how do we find it? I take angle 3 and add it to 4. More vocabulary. What were 3 and 4 called? Remote. Interior angles. Good. Now I'm going to take it a step further today. The first fact today says this. Wait a second. Time out. If angle 1 is equal to 3 and 4 added up, shouldn't angle 1... It's all right. You keep that close window. Here we go. Everyone see that one? If angle 1 is equal to angle 3 and 4 added up, shouldn't angle 1 be bigger than angle 3 all by itself? Make sense? And it also should be bigger than angle 4 by itself. That's the first fact today. All right, an exterior angle will always be bigger than either of the, what are these called one more time? Remote interior angles. All right, always. And that's what the first theorem says there on your paper. All right, so let's apply it. Take my diagram right here. Could somebody give me the exterior angle for almost made a mistake there. For triangle ABC, what's the exterior angle? Oh, 60. No. That's unfair to 18 through 28. 13. Exterior angle for here. Angle DCA will now be bigger than, name a remote interior for triangle ACB. 15. A. Angle A. It's bigger than A. And it will also be greater than 7. Angle B. Notice what it does not bring up. I cannot tell you the relationship between these two. All I can tell you is they equal to 180. I can never tell you what's bigger and what's smaller. I can only tell you the exterior is greater than either of the two remotes. Can't tell you squat about the one next to it. So don't fall in. Oh, it looks like it. Okay, where have you been for the first quarter? We don't go by looks like it. Okay. All right, you and your group have a challenge in the next 2 minutes. And just throwing this out there too. Period 5 could do it. Our period 7, last period, could do it. And you know how their averages go. All right. Find all the angles that are less than angle 7 in this diagram. And there should be 5 of them. 5 of them. Let me get you off on the right start, you and your group. Angle 7 is an exterior angle, isn't it? And it's an exterior angle to how many triangles?
1, 2.
I see 7 is an exterior angle for 2 different triangles in here. So that must mean it's bigger than its remote interiors. 2 minutes. Go right ahead. How many angles are less than angle 7? Angle 7 is bigger than, boom. All right, I understand. Some groups think they have all 5, but that doesn't mean everybody in your group understands where all 5 are coming from. So let's go over this. Name one triangle right now. Angle 7 is an exterior angle for. That's where I need to start. Name a triangle where 7 is an exterior angle. Let's roll 11.
MKL.
Okay, let's start with MKL. Everyone's in agreement. Here's triangle MKL. 7's exterior. Give me the 2 remote interiors then. What are the 2 remote interiors right now in triangle MKL if 7's the exterior? 25. Name the 2 remote interiors.
5 and 4.
5 and 4 should have been on your list. All good. All right, you guys told me though before I let you go, there was 2 triangles where 7 was an exterior. What's the other triangle? It's an exterior angle for 20.
JL. Okay.
The big dog, right here. JKL. All right, so if 7's the exterior, if 7 is the exterior for that triangle, what are the two remote interiors then, right? What are the two remote interiors to 7? Let's roll. Whoa, 12.
J and JKL.
Okay, I'll go angle 3. And JKL, good. Any issues with those right there? Those are probably the 4 that you should have got. The 5th one's a little trickier because it has nothing really to do with an exterior being bigger than the remote interior. How do I get the 5th and final one? I go off of that angle. What's JKL made up of? Angle 2 and angle 4. So shouldn't 7, if 7's bigger than the entire angle, shouldn't 7 be bigger than its parts? I already have it's bigger than 4. It's also bigger than the other part too. There are your 5 angles. Questions? All right, another challenge. Number 2. Same diagram. Find any angle that's bigger than 6. And this one's a little bit easier because there's only 2 options that are bigger than 6. Go right ahead. 2 angles that are bigger than 6. 7 obviously should not be coming out of anybody's mouth. 2 angles bigger than 6. Let's first start. Angle 6 is an angle in triangle MKL, right? Can't say angle 7 because that's right next to it. Where's the other exterior angle up here that makes 6 a remote interior other than 7, which we know we can't have? 7, huh? Where's the exterior angle to 6? 1. All right, 1 is one of them. Thought we were going to go different. Everyone see angle 1? All good? Angle 1? Yes? No? Okay. And is an angle 6 an interior angle in another triangle? There we go. Right here. And what exterior angle would make 6 an remote interior? Oh, 6. Angle? Angle 8. Alrighty. So that was it. Yep.
Can I say angle JML?
JML, because it's just, why don't we just name all the straight angles then? All right. Other questions? Anything else? All right, that was decent, right? Decent. Now let's get to an honors level question. And it's multiple choice, which is rare. Woo! AB congruent to BC. What is this, a proof? AB congruent to BC. Stop. Are we, hey, wheels turning at all? Forget about the question. AB congruent to BC. Oh, boom, this happens. AB congruent to BC. Boom, this is true. What else are you marking then? Angle 1 is also congruent to BC. A, there you go. I don't know if I'll need it, but I know it's true. The more facts I have, the better off. All right, which one of the following statements is true? All right, they basically, one angle is bigger than the other. Great. Which one's true? Ooh. And we're not going by looks. We're not going by looks. Oh, geez. Is 1 an exterior angle? 1 exterior?
No.
Nope. How about 2? 2? No. How about 3? Is 3 an exterior angle? Nope. How about 4? Wow. None of these choices have anything to do with exterior angles, so I'm going to have to try to find my way around this now. Yes, 1, 2, 3, and 4. None of them are exterior angles. But didn't we write something here right away? 1's congruent to BCA. Anybody notice anything about BCA? Is BCA an exterior? Oh, darn right it is. Angle BCA is an exterior angle for triangle BCD. Everyone see it? I'll extend it there for you right here. All right, let me know then. Then that angle's got to be bigger than BCA has got to be bigger than 3 and 4, right? Well, let me just start with angle 4, and then if I need it, I'll put in angle 3. So BCA is bigger than 4, huh? BCA also has the same measure as what?
1.
Oh, wait a second. So if BCA is bigger than 4, so should angle.
1.
There you go. This is actually a substitution you used here. Everyone see that? Angle 1 is the same as BCA, so angle 1's got to be bigger than 4 as well. And if that wasn't an option, maybe angle 1 was bigger than what other angle? 3. Yep, because BCA was 3. Bigger than 3. Questions from you guys? Are we okay on this theorem? Exterior bigger than either to remote, because I got the second big theorem of the day coming up now. Comments, concerns? We're all good? All right. I refuse to tell you the fact here. I think some of you already know it from middle school, actually, but we'll see. So I drew 2 triangles for you. Do you see each triangle is missing an angle? Okay, your first job is to find that missing angle, which shouldn't take you long. Your second job in your group, and again, I will wait for however long it takes, is you're going to look at both triangles and see if there's a pattern between the sides and the angles. Okay? So go ahead. Your first job, find the missing angle in each, and then look at both triangles separately and see if you can find a pattern between their sides and angles that exist in both. A lot of different theories out there, I'm hearing. A lot of different theories. It has nothing to do with what the actual angles and lengths are. It's not like, hey, take this angle, multiply by 3, and add 4, and then divide it by 2, and you get the side. And that's not what we're looking for. All right, it's the position of the angles and the sides. It's the position. And I heard the correct answer a couple times. As we usually start, in a triangle. What did you notice about the sides and the angles and their positions? What's 82 in that triangle? Largest angle, isn't it, out of the 3? And it conveniently is across from where? The largest side. Is that true over here? 105? 25? Thanks, Miles. Appreciate it. Have a good one. Isn't it 105 across from the largest side? There it is. So in a triangle, biggest side is across from biggest angle. And guys, ladies, you could easily substitute in the word smallest here. Biggest, I did that again. Did the same thing last period. Biggest side is across from biggest angle. Largest, if you'd like. All good? So there's your second big fact of the day. Let's do some basic problems before we end up finishing off class with some honors ones. So I have 2 triangles. I'd like you to list the sides from shortest to longest. Shortest side first, longest side last. That's going to be a problem unless I know what?
All the angles.
Oh, yeah. Knowing all 3 angles would be nice. So angle B. When you have it, angle B. Oh, 13, angle B. Anybody got 13? Oh, all right. Whenever you're ready. 92? All right, let's rank them. Shortest to longest. Shortest to longest. We'll go up 25. Shortest.
Let me see.
Next,
BA.
longest.
CA.
All good? Any issues? We got a little more work to do on number 2, right? Because now you're missing 2 angles, but shouldn't be a big deal because I gave you the exteriors 107. Three, when you're ready, I'll take those other angles.
For number 2.
Yeah.
SR.
No, whoa, just the angles. I just need the angle. I don't need the rankings.
Sorry.
Yeah, that's somebody else.
32.
32 for T, SRT 73. All right, now I'll take the rankings. Shortest first. 20.
SR.
SR, followed by
ST.
ST, longest
RT.
RT. Basic concepts, all right. Let's go middle school level. Ooh, which one of those statements is true? Well, if it's going to be isosceles, that means it has 2 congruent angles, right? If AB is the longest side, the angle across is the biggest. Same thing with choice 2. And if ABC is an obtuse angle, I'm going to have what type of angle? I'm going to need an angle bigger than what? 90, right? 180. Ooh, bigger than 90. Can you guys help me find what the actual angles are? How can I use the given information to actually figure out how many degrees are in each angle? What do you want me to set up? 7. There we go. Add them all up. Set them equal to 180. 180 degrees in every triangle. And I'll let you guys go. Go ahead. Find X, plug it back in, and then I'll ask somebody what those angle measurements were. All right, help me out. What are your angle measurements for A, B, and C when you have them? 17.
B equals 45.
What do you have?
For B equals 45.
What'd you get for X?
Oh, 16.
You're better than that. What do you got? 10X, right?
Yeah.
Minus 20.
20, yeah.
Add 20.
Yeah.
10X equals 200.
No. Oh, wait. I subtracted instead of adding.
One job. One job, Riley. Come on, fix it. You got it now. Don't get rattled. This is what gamers do.
20.
20. Plug it back in. Let's roll.
A equals 60.
Okay. Yep.
B equals 61.
And the second thing gamers do, they finish.
And C equals 59.
There we go. All right, let's answer the question now. Is this isosceles? Absolutely not. is AC the longest side? Why is AC the longest side? Explain. 1. Why is AC the longest side? Job. 17. Why is AC the longest side? Redemption.
It's across from the biggest angle.
Third thing gamers do, they don't let lightning strike twice. There we go. Questions? Now you're ready to go to the honors level. I am changing the directions on here to make it a little tougher. Please change the word longest to shortest. Please change it to shortest. Now, in the entire diagram, I'm asking, not each triangle, in the entire diagram, what segment is the shortest? Well, we're not even going to discuss that until I know what? All the angles. So I need to find the missing 2. Go ahead. And we have angle BDA was 60. And angle DBC, 57. We're all good? So I would totally understand right now, based on our discussion today, somebody looks at the diagram. Oh, the shortest? Well, in the diagram, 53 is the smallest angle, and the side across is BD. My answer is BD. No. What did you just give me? You just gave me the shortest side in triangle BCD. That might not be the shortest side overall. So how are we going to figure this out? We are going to take each triangle right now and rank their sides and look at the rankings and see if we can figure out, based on the rankings, what's the shortest side overall. So let's start with triangle ABD. Rank their sides from shortest to longest. Who is up? 18. Shortest. AD. Good start. Next. BA. Yep. And longest? BD. Got it. And let's compare that to the shortest to the longest in triangle BCD. What do you got for me? Rank them. 7. Shortest. BD. Next. DC, followed by BC. Yep. All right, we're ready. I'll go slower here so the explanation is very clear. We're looking for the shortest side, right? So it's going to be a battle between the 2 shortest sides in each triangle. It's a battle between these 2 of who's shortest overall. Got to be. It's a battle between those 2. One's got to be shorter, the shortest overall. Look at your rankings, please. By yourself in your group. It is impossible for one of those to be the shortest overall based on our rankings. It's impossible for one of those 2 to be shortest overall. Which one is it impossible to be shortest? How, ready? Let me go slow. How can BD be the shortest if over here you ranked 2 other sides shorter than BD? Isn't this what this means? Which one's shorter, BD or BA? So how can BD be the shortest one overall if you just told me there's another one out there that's shorter than it? Everyone see where I'm going? So no way can it be BD. It's got to be AD. So you cannot just go by the degree measures. That's only for a single triangle, not an entire diagram like I have here. So AD. All good. All right. I am going to let you find the shortest side in this diagram, and then I have a challenge question at the end, because that's the honors level we're in. So go ahead, find the shortest side in this diagram, but do not pack up or stop, because I have a challenge question afterwards.
I did not even realize.
How do we look here? So we ranked all the sides, right, in both triangles, and now it's a competition between YA and VA, right? Which one's those two are the smallest sides in both triangles. But if you look at your rankings, it should be impossible for one to be the shortest overall. Definitely can't be which one out of those two? It can't be YA. Look, right here. You have already listed 2 sides that are smaller than YA. So YA cannot be the smallest overall. It's going to be VA. And now here's my challenge. And I'll end class on, and you and your group can go. Rank the rest of them. Rank the rest of them now. I know VA is the smallest. What's next? What's next? What's next? What's the biggest? Use your rankings to your advantage. I know VA is the smallest. What's next? And so on. Use your rankings. VA's gone. Rank the final 5. Shortest to largest.
No, I said V. Oh, yeah. Why did you?
What do you mean you're not there?
All right, next up. Is it going to be YA next? Because we just said it's a debate, right? Those are the 2 smallest sides. So if I already limited that, that's got to be the next smallest side. Guys, it's the same argument. What did you already write as smaller than YA? Right here. Everyone agree? YV is you wrote that. That YV was smaller, so it's got to come next. Now what's next? Now I can go YA. And out of the 2 remaining ones, because you rank them like this, what's the next smallest one? NY. And then the largest one out of all 5 of them, NA. Well, I got one other thing before we pack up, because I know it's going to be on tonight's homework, and I don't want you to skip it because I didn't remember or we're too lazy to go look it up. You're going to need this bad boy on homework tonight. Anybody want to fill in the rest of it? What is this, by the way? All right, just making sure. Yeah, you're going to need it when there's a graphing question tonight. So even if you don't graph, you're still going to need it. All right, we're good.